My fellow mathematicians, welcome once again, yet another video. Now this is part 4 of our analytical geometry of June revision 2025 series. Now in this specific video in here, we are not gonna be doing anything difficult at all other than us going into the deep and nitty-gritties of it. So in the context of solving. So before we solve, we first handle the comprehension. So if you are seeing this, if you've bumped into this and you haven't seen the last 3 videos, this is video number 4 of our analytical geometry series. Please go and watch those, otherwise I'm just gonna sound like I'm talking some jibber you know nothing of. Anywho, going forward, let's look at the first question. Question 1 we have on the left in here. In question 1, they say in the figure below, ABCD is a parallelogram with vertices A and the coordinates of A given, B, the coordinates are also given at B, C, coordinates also given, and then there's D. At D, however, we are only given one coordinate, the Y coordinate. The X coordinate is not given at D. So the X coordinate is unknown at D. It's given as what? Our K. At D, the X coordinate is given as K. So we note that to ourselves. So what's happening at D? We dare ask ourselves. At D, the two lines are intersecting. Which line is intersecting which line? Line AD is intersecting line CD. That is essentially to say at point D, the equation of line AD is equals to the equation of line what? CD. Why? It's a point of intersection for the two graphs. Just like at point A, the equation of line AD is equals to the equation of line AB. So at any point of intersection, the two lines or the two graphs that are intersecting are equal. So that's something for us to note. Why are we noting that? We are noting that because we know that every straight line in here is a straight line function, and we know that because we could be asked to calculate the coordinates of D later on in the question. Now notice at this point we don't care much about the questions. We are just still trying to make sense of the bigger picture. Just as I am trying to make sense of the bigger picture with you in here, that's just exactly what you will be doing by yourselves. Right, we haven't finished reading our scenario in there. We just read the first sentence and then go to put some meat to the bones, right? Dressing up our skeleton. Right, so they say AF is perpendicular to BC and parallel to CG. AF has a 90-degree angle with BC. Has a 90-degree angle with BC. That is to say, the gradient of AF multiplied by the gradient of BC is equals to what? -1. Why are we saying this? Because we know already that when we have two lines that are perpendicular to each other, as in this case in here we have two lines that are perpendicular to each other meeting at 90 degrees. Whenever we have such two lines, the product of their gradients is always equals to -1. As such, That's exactly the same deduction we came to say, oh, if we multiply the gradient of AF and the gradient of BC, they should give us what? -1, seeing as the two lines are perpendicular to each other. Now they also say that they also say that AF is parallel to CG. Now that's important to us. Why is that important to us? Why is it important? AF is in here and GC is in here. Now this GC and AF are parallel. Why is that important to us? That's important to us first and foremost because of what we know about alternate angles. Alternate angles are equal to one another. So whenever we have two parallel lines, let's say this parallel line in here and this parallel line in here, and then we have a transverse line between the parallel lines, that is to say the angle between the first parallel line and the transverse line is going to be equal to the angle between the other parallel line and the transverse line. I say again, parallel lines, the angle between the transverse line and the parallel line is equals to the angle between the other parallel line and the transverse line. That's how we see alternate angles. That's what alternate angles are. So with that in mind, we notice, okay, so that might be the same thing we have in here, Moose. How so? I'm just going to extend the line GC just a little bit. This is point G in here, point G in here. I'm just going to extend this line just a little bit. Why am I extending it? I'm extending it because I want you to take note of this angle in here. So if this line is parallel to this line in here, this simply means that these two angles are what? Alternate angles. So this is a 90-degree angle. Again, we are still gaining sight of the bigger picture, building that comprehension. We are not answering questions yet. This assessment that I'm doing with you, that's exactly what you will be doing with yourself every freaking time you are answering a question. Even during that exam you are so soon gonna write. Moving forward, and then they say E is a point of intersection of the diagonals. Now E is a point of intersection of the diagonals. An important thing for us to note as well is that they said this ABCD is a parallelogram. Now, what of a parallelogram? A parallelogram has two opposite sides that are equal and parallel. Opposite sides that are equal and parallel. But not only that, a parallelogram also has diagonals that have something that is of interest to us. Now, with the diagonals of a parallelogram, they cut each other in half, or to speak a mathematical language, they bisect one another. The diagonals of a parallelogram bisect one another, meaning this diagonal in here is going to bisect with this diagonal in here, which is also this one bisects that one. So if we had A, B, C, D in here, and then we had an E. E is equals to EC, just as DE is equals to EB. That's always the case with the diagonals of a parallelogram. Also, the diagonals of a parallelogram meet at 90 degrees. They are perpendicular to one another, meaning the gradients, the product of the gradients of a parallelogram is equals to what? -1. Coming back to our scenario, we are still building the narrative. Narrative building is very important. So now that we know that, oh, the diagonals of a parallelogram bisect one another, so we know that, okay, this means that EB is equals to ED, which is also equals to what? AE, which is equals to AEC as well. Also, we know that, oh, the diagonals of a parallelogram meet at what? 90 degrees, meaning a line AC is perpendicular to line BD, right? So the story now is starting to gain some color. We are starting to gain some understanding as to what to expect going forward now. It's making sense, ne? Moving on. Now, it's also important for us to note that seeing as ABCD, it was said that ABCD is a parallelogram. We know that opposite sides of a parallelogram are what? Parallel and equal. Opposite sides are parallel and equal. Opposite sides are parallel and equal. Meaning in parallelogram ABCD, the same is going to be true. This side is going to be parallel to the opposite side, and it's also going to be equal to the opposite side. Just as this side in here is going to be equals to this side, and this side being equal, parallel to this side in here as well, right? So why is that important? That's important to us because we have this straight line being parallel to another straight line, and this straight line being parallel to another straight line. That's important to us because whenever we have two straight lines that are parallel to one another, their gradients are always what? Equal. If we have line AB being parallel to line CD, that gradient of line AB is always equals to the gradient of the line that is parallel to it, in this case CD. So this specifically speaks to us when we are looking at now our question in here. When we are looking at our question in here to say, oh, that then must mean for us that the gradient of line AB, seeing as AB is parallel to line DC, then the gradient of gradients of those two lines must be then what? Equal. Oh, we can make that deduction. Just as line GC is parallel to line AF, so then the gradient of line AF is equals to the gradient of line what? GC or CG, right? What other lines are also parallel? Oh, this line AD is parallel to line BC. So that then means the gradient of line AD is equals to the gradient of line BC. Is that making sense, ladies and gentlemen? Now, right. So that's us. We've tried to make sense of the bigger narrative. So this first 13 minutes and a half, that's exactly what you're supposed to do every time you encounter such type of a question. Make sense of the bigger picture before you go in. And now, granted, it's not going to take you 13 minutes when you do it for yourself, by yourself. It doesn't take me 13 minutes when I'm doing it for myself, by myself. It takes me actually like 10% of that much time. So, however, once we have that narrative now, we can now start trying and attempting to answer questions. Now, let's look at the first question. The first question says, determine the length of BC in the simplest surd form. So, where is line BC? Oh, we have point B in here. We know the coordinates of point B, and we also know the coordinates of point C. Or calculate the length of BC in the simplest surd form. So whenever they say calculate the length, whenever we have to calculate the length, we don't think much. So for 1.1, it's a no-brainer for us. We have to calculate the length. When calculating the length, the first thing that comes to our mind is what? The distance formula. Whenever you're dealing with distance or length, the distance formula, that's the go-to strategy, which is x2 minus x1 squared plus y2 minus y1 squared, right? That's our distance formula. Now we've got 2 points in here, so I'm gonna call point B the first point and then point B the second point. So let's go ahead and substitute now into this distance formula of ours. Substitute the coordinates of these points. Now the second point is what? Point C. So x at point C is 8. So I'm going to substitute my 8. My formula has a minus. Now my x also has a minus. My x1 also has a minus. So minus and a minus is going to give me a what? A positive. So that is my positive 2 squared plus bracket y2. My y2 is what? 1 at C. The equation has a minus of itself. My y1 is minus 4. So a minus from the equation and a minus from my y1, it's going to give me negative times negative gives me a positive. So hence I'm going to have a plus 4 squared, and then I put everything as is in my calculator. It's going to be 10 squared, which is 100, plus 5 squared, which is 25, 125 square root, they said in the simplest third form. So the simplest third form, it's 125 what? Units. So the distance then of BC is a root 125 what? Units. Always when you're calculating the distance or the length, right, you have to define your units. If you don't define your units, you essentially can be penalized for the final answer, even if the number you wrote there is correct. So that's it for 1.1. We've answered everything we needed to do. So let's go ahead now and chop down 1.2 together. 1.2. What's happening in 1.2? They say now calculate the gradient of BC. So we were just now calculating the length of this very same line BC. Now we have to calculate the gradient of what? This line BC. Now there are two ways to calculate the gradient. One is using the angle of inclination, which is the angle between the line m is equals to 0 or the x-axis and the graph or the line itself. One other way is using 2 points on this particular line. Do we know the angle of inclination? No. Do we know any 2 points on this line BC? Yes, we know the coordinates of B, we know the coordinates of C. So then our strategy has been cut out for us. Then let's go ahead and calculate the gradient of what? BC. The gradient of BC is going to be defined by the change in y over the what? The change in x. That's our equation for the gradient given 2 points on a straight line. So I'm going to maintain this as my point 1 and this as my point 2. Right, at point 2 my y is 1. The equation has a minus of itself and then there's a minus there. So I'm still going to have a plus 4 all over x2. My x2 is what? 8. The equation has a minus of its own, and then my x1 is minus 2. So negative times negative is going to give me a positive 2. Therefore the gradient of BC is equals to what? 5 over 10, which is 1 over 2. Done and dusted. Then, just like that, we've got our 3 marks, ladies and gentlemen. Was that hard? Now, I'm going to pause here, break this video into the first part. Now, before you look at the part 2 of the video, in which part 2 I'm going to be continuing with this very same exercise in here. We've done 1.1 and then we've answered 1.2. Now, I'm going to be in part 2 of this revision paper. I'm going to be going from 1.3 all the way into the last question, right? Breaking them off. But I'm asking you that with the narrative that I've built for you, with the narrative that I've built with you, could you please be so kind as to attempt 1.3 all the way to 1.7 by yourself before you watch the next video? That is that, my good people. I'll be seeing you in the next one. Mind you, we are gonna be continuing with the revision to what we've been doing, right? So I'll be seeing you in the next one. Thank you very much. Thank you for your attention. Keep up the spirit. Keep fighting the good fight. Remember, it's like Tony Robbins said, repetition is the mother of what? All skill. So keep going at it.